Hi, good morning. Today we will be discussing about enterprises and distributed network. In this chapter, introduces some devices that allows the expansion of network locally or across the world. First, you learn about modems, the basic communication tools that lets computers communicate using conventional telephone lines. Then the different types of communications lines or carriers are discussed. And finally, you will find about products that make it possible to expand network and some segments. So first, modem. When we say modem, it is a tool um, that connects to the computers over the line or TV or cable line, effectively extending a network beyond a local area. So in other terms, it is a device that enables a computer to send or receive data over telephone or cable lines, as what I've said earlier. The data will be stored on the computer is digital, whereas a telephone line or cable wire can transmit only analog data. The main function of the modem is to convert digital signal into analog and vice versa. Modem speed. Modem speed is measured in the number of bits per second that can be transmitted. V0 standards developed by the International Telecommunications Union. When we say asymmetric communication, it is a communication in which data travels in the download direction at a speed different than the upload direction. So here is an example of modems and network communications. So basically, there's a computer, and then it is connected to the modem, which the signal or the digital signal will arrive. And then there's a modulation and demodulation, which the telephone line or the analog signal will be transmitted to modem and then will be transmitted again to the computer. So now let's proceed to digital modems. Another increasingly prevalent modem type is the digital modem. So another term for that is the integrated service digital network, or sometimes referred as to a digital modem. Usually, digital modems uses adapter for international service digital network that will consist of a network termination. But however, because most users are familiar with the term modem, manufacturers of these NT or TA devices often uses that term. Next, telecommunication carriers offer a competing digital technology called digital subscriber line. Typically, such companies includes local long-distance companies, local exchange carriers, and digital carriers like COVID and Quest. To deliver digital service, DSL uses the digital-only carriers such as COVID and Quest to same twisted pair telephone lines that deliver voice telephone service. Unlike cable modem connections, DSL connections are not shared and thus offer their subscribers guaranteed bandwidth. So let's now proceed to Windows 2000 or 2003. For your network to be even more effective, you may need to allow users dial and access from their homes, remote sites, or hotel rooms. A simple way to accomplish this is in a Microsoft Windows 2000 or 2003 server networks, is to use the Windows 2000 or 2003 Routing and Remote Access Service or PRAS. So in definition, supports for remote access service which permit up to 256 users to dial in a server to obtain remote access to the network to which service is attached. And now let's go to virtual private network. It allows remote access clients to connect to the corporate network securely through the internet. In other terms, users need also connect to local internet service provider (ISP) and establish a virtual private network to connect. So VPN, or the virtual private network, represents temporary or permanent connections across a public network such as the internet that use a special encryption technology to transmit and receive data. So repeaters. A signal that travels along the cable degrades and becomes distorted through attenuation. If the cable is long enough, the signal eventually becomes so degraded that it's so unrecognizable. A signal that travels along a cable degrades become distorted and through attenuation. As shown in the figure, repeaters accept a signal that claims it and resignates that sends it down the line and effectively doubling the length of the network. So that's for all. I will now give the presentation to Bran Raziel Oclarit to further discuss the discussion.
So, the continuation of the report. What are repeaters? In telecommunications, a repeater is an electronic device that receives a signal and transmits it. Repeaters are used to extend transmissions so that the signals can cover longer distances or be received on the other side of obstruction. So in this illustration, it illustrates how repeaters are work. They transfer signals from point A to point B, and the hill being an obstruction, they can typically bounce it off at another range in order for point B to receive the signal. Some types of repeaters broadcast an identical signal but alter its method of transmission, for example on another frequency or baud rate. There are several types of repeaters. A telephone line repeater is an amplifier in a telephone line, and this is what telephone lines look like. And an optical repeater is an optoelectronic circuit that amplifies the light beam in an optical fiber cable. The example on the right side is the optical electronic circuit cable that amplifies light beams. And a radio repeater is a radio receiver and transmitter that transmits a radio signal. They typically use this to initiate attenuation in networking. So, what is attenuation? Is loss of signal strength in networking cables or connections. This typically is measured in decibels or dB or voltage that can occur due to a variety of factors. It may cause signals to become distorted or indescribable. An example of this is Wi-Fi signals and strength getting noticeably weaker the further that your device is from your router. So, what are switches? Switches are similar to bridges, but their advanced technology allows them to handle more network segments and switch frames much faster than bridges. Three primary switching methods are cut-through, store and forward, and segment-free. So, let's discuss each of these kinds of factors. So, each of methods. So, cut-through method. In computer networking, cut-through switching, also called cut-through forwarding, is a method for packet switching systems wherein switches start forwarding a frame or packet before the whole frame has been received, normally as soon as the destination addresses and outgoing interface is determined, compared to store and forward. This technique reduces latency through the switch and relies on the destination devices for error handling. Pure cut-through switching is only possible when the speed of the outgoing interface is equal or greater than the incoming interface speed. So, how cut-through works is they send a signal. There's a weakness to this because the error checking comes from the one who receives it. That's the error of this kind of method. So, the next is store and forward method. Store and forward switching means that the LAN switches copies each complete frame into the switch memory buffers and computes a cyclic redundancy check or CRC for errors. If the frame is error-free, the switches forward the frame out in appropriate interface port. So the store and forward is is kind of like addresses the weakness of the cut and through, meaning that from PC1 it sends it to the switch and it checks for errors, then it forwards it to PC2. That's what it means to store and forward. The last one would be the fragment-free method, most commonly referred to as a compromise between store and forward and cut-through switching, meaning that it's kind of the best of both. This method involves storing the first 64 bytes of the Ethernet frame in a buffer, then forwarding it. So it stores half of or 64 bytes of the message you're sending, just like what store and forward does. Then it gets forward, like the cut through. So it's like the best of both worlds. So the last is, what are routers? Routers connect several independent networks to form a complex internetwork, able to connect networks with different physical media like a bridge. A router can also connect networks using the same protocol but different networks architectures, such as Ethernet and token ring. And network in multiple paths. A router can determine the best path for a packet to take to reach the destination. So what it means that it can be done with different network architectures. So for example, this is an example of how a router works. And these are the different types of architectural formats, like the ring topology, which is on the top left, and on the the top right is the bus topology, and the bottom part is the countless types of topology. So you can incorporate a router when you're trying these types of architectures. So that will be all for the segment of my report.
Static routes. A router always sends the packet along the same path. Using static routes, a router always sends the packet along the same path. But if a router uses dynamic routing, it makes a decision on which path to send the packet based on the cost of the packet traveling a particular path. Dynamic routing. If multiple routes are available to a particular network, the router decides which route is best and enters the route in its routing table. A router chooses the best path for a packet in two ways, using distance vector algorithm. The router calculates the cost of particular route based on factors such as the number of routers between the two networks, just like hop count. Using link state algorithm, the router relies on the speed of the links between networks to determine the lowest cost path. RIP, or Routing Information Protocol, is one protocol through which routers learn and advertise the path available to them. So RIP is a distance vector protocol that uses the number of routers, hops, along a path to determine cost. OSPF, or Open Shortest Path First, is a link state routing protocol that determines a packet's best path by taking other factors into account, including line speed and network congestion. Let's proceed to routers, bridges, and routers. Routers combine the best features of bridges and routers. When routers receive a routable packet, it operates as a router by choosing the best path for the packet and forwarding it to its destination. However, when a router receives a non-routable packet, the router functions as a bridge, forwarding the packet based on hardware address. So, gateways are the most intricate network device because they translate information from one protocol to another. They generally operate at the upper layer of the OSI model. For example, a gateway can allow network communication between a TCP or IP LAN and an IBM mainframe system using System Network Architectures or SNA. Another example of a gateway is a system that converts Microsoft Mail to Simple Mail Transport Protocol or SMTP for transmission over the internet. So that's all. Thank you.